Okay, here we are. The final CCNA of the final CCNA. Not really, I guess there's a CCNA4 that'll be activated after this. But hey, this is the last chapter, like this, of the CCNA content. All of CCNA5 is like a Wikipedia page. Woo! Okay, here we go. Troubleshooting everything. Troubleshooting the network. Explain how network documentation is developed and used to troubleshoot network issues. Describe general troubleshooting processes. Compare troubleshooting methods that use systematic layered approach. Describe troubleshooting tools to gather and analyze symptoms of network problems. Determine the symptoms and causes of network problems using layered model. Troubleshoot a network using the layered model. Okay, so basically most of this will probably be stuff you've heard of in the other classes, maybe. Yeah, it's going to be a good time. Alright, so documenting the network. This one's important. Okay, so not just what they're showing here, not just charts like this, that's what they're showing, and model names and that. Whenever we talk to employers say, you know what your students need to do better? Document. So documenting the network, documenting everything is better. So we'd use probably something like Visio and actually diagram it all out. But this is a different way of showing exactly what's going on routers. This one would be just switch, right? So yep, 2960. Then we have our PCs, but we still don't have the picture. But some other things document. Configure files, including network configuration files and end system configuration files, physical and logical topology diagrams, a baseline and performance level. Okay, so I don't even consider some of that documentation. But anyways, documentation, the type and model of what you have, the ISO name on our configuration files, because we can rebuild devices this way. You know, we can throw this on TFTP server. If something stops booting right, we could, you know, load from the TFTP hopefully. End system configuration, device name, what it's doing, operating systems. This would be more like images in my opinion. Hopefully people running, or hopefully the computers you deploy, you know what's going on them. And we want the default gateways, DNS, yeah, sure. That's probably a good idea. I think a lot of that we could figure out. Once again, if we had a map, a Visio map, probably be the best, and would include all this. Here it is! This is what I definitely want. Or actually I'd probably do the logical. So just do the logical rather than what's the physical. As you can see, it doesn't have our IP addresses, but it says where it's connecting and all that. Both of these would be a great idea. But if you were to have one, at least have this one. So the physical topology has types, models, operating systems, cable types, cable specification, cable connector type. The logical has device identifiers, IP addresses, interface IDs, connection types, DLCs, site-to-site VPNs, routing protocols, static routes, data link. Yeah, I think you guys can probably figure that out just by the pictures. Alright, so next we have baseline. And so I guess, yeah, this is good documentation. Great documentation. How does the network perform during a normal or average day? Can the network meet the identified policies? What part of the network is most heavily used? What part of the network is least heavily used? What alert thresholds should be monitored? Alright, the network baseline determines the personality of a network under normal conditions. Alright, so the most important part of this is how would we find this normal thing? So this would be over time. Initial baseline also tends to reveal hidden problems. The collected data shows the true nature of congestion or potential congestion in a network. It may also reveal areas of the network that are underutilized and quite often can lead to network redesign efforts and quality and capacity observations. Alright, so measuring it, a network administrator needs to determine the difference between abnormal behavior on the network, proper performance as the network grows with traffic patterns. The baseline also provides provides insight into the current network design. It's one of these ways that, if you guys have heard of constant persistent threat and security, the baseline shows us that, wait, this is just kind of out of whack. Why is this happening? So right here is probably the most important. Establishing a network performance baseline requires collecting performance data from the ports and devices that are essential network operation. No, that's not what I want either. I want when we do it. Okay. Step 1. Let's determine what we're going to collect. Identify devices and ports of interest. Okay. Determine the baseline duration. The length and time of the baseline information gathered must be sufficient for establishing a typical picture of the network. It is important that the daily trends of the network traffic are monitored. It is also important to monitor trends that occur over a longer period of time, such as weekly or monthly. That's what I'm saying, is this baseline needs to keep being done to figure it out, to actually have a good idea. What are they using here? Cisco Wide Area Application Services. Sure, there's lots of SolarWinds products that could also help us establish a baseline. Planning. I mean, hopefully you guys can figure out that we should go on these routers. Why the routers? We definitely have a single point of failure here. We definitely want to make sure we're not maxing out those interfaces, stuff like that. Anyways, it's pretty neat. And then we want to go into something like this. So, I don't know. I don't remember where we're at. But anyways, we want to establish baseline over time. This graphic right here, I don't know what it's showing is, I don't know, when we see some strange stuff happening in our CPU usage of our devices. Probably where we're getting this information again is if we want to go back to the last chapter. SMMP is allowing us to do some of this stuff. Alright. Measuring data. What is this one? Oh, you guys ever heard of ping, traceroute, or telnet? As well as the show commands? Okay, so this is going to be fun. We can already tell. Alright, so it's stuff, I don't know, shows tech support. This command is used for collecting a large amount of data information about the device troubleshooting purposes. It executes multiple show commands, which can be provided technical support restaurant. I don't know. That's the only one I haven't really seen. Show IP clash flow. This is going to be our NetFlow stuff. These other ones, hopefully, you recognize. Show interfaces. That's a big one throughout all the CCNA. Show IP route. Alright, that's going to show all of our routing information throughout. We've seen that many a time. IP version 6. Show ARP, and the inverse on IP version 6 of show ARP is show IP version 6 neighbors. Show run. Show port. I've never used show port actually either. Huh. Anyways, what we can guarantee is this test is probably going to have some weird show commands. Anyways, I guess that's how we look at data, and then it's showing us what is this one for? I don't know why it has the show commands with that, but anyways, hopefully you do. Okay, we don't need to do that document impact tracer. Alright, general troubleshooting. Hopefully you guys, I think you guys probably are somewhere in here. Probably could figure some of this stuff out. Gather symptoms. What does this mean? What were you doing when this started happening? Isolate the problem, right? This is one of the reasons we use traceroute or ping, is to figure out where our network is failing, or if it's not a network problem, I guess, what application is, why the application is crashing, what is it crashing, blah blah, you know, something like that. Stage 3, implement corrective actions. I think as you can see from the next if-then statement, implement corrective actions. I think this is going to fix it. Did it fix it? Yes. Did it not? No. Crashed the whole network. Okay, so if we did fix it, here's another place to document. We want to document how we fix things, because if we have that problem again, we can't quite remember. Maybe we can go to our documentation and say, oh, here is the what are they, like SOP. We got the SOP for that, right? There we go. It's the standard operating procedure. So, gathering commands, ping, traceroute. Take that, telling that out. This is not. Let's say SSH. Show these interfaces. Well, they're going to show if our interfaces are up, right? That's probably the best thing, and that we're in the correct network. Show IP route. Definitely, if we're having a problem getting somewhere, probably go here first before any of the other ones. Show run be my next go-to, but you guys probably already know that. Show protocols. I've never really found that useful, but I guess if you were having routing issues in your show IP route, this could maybe come up with something. Or we could debug. And so debug, we don't do a whole lot of that because Packet Tracer doesn't do a great job of it, but it'll just show you a lot of nice things about everything from EIGRP to OSPF to NAT, right? Debug, which I guess in this CCNA4 it's kind of showed some debug graphics. Questions to ask end users. I'm going to let you guys read those because I think you can figure them out. Alright. OSI, using a layer troubleshooting model. Alright, so hopefully you guys remember we have shoot from the hip model. I can't remember what it's at. I don't know, we could probably call it start in the middle, or we have top down, right, where we start from the application at layer, see if where the problem is, or from the bottom up, where we start with, do you have power? Alright, do we have net blink? Are we getting IP addresses? Is an ACL blocking this? Is the session, I don't know, I just go straight to I keep all of these as the same. But what they're talking about here, right, is we're using one of these models to make sure we are actually we can isolate a problem fairly easy, right? That's what these models actually are for. Besides that, we learn them so that we can learn how to isolate the problem. Okay, divide and conquer. That's the shoot from the hip in the middle one. So this one, bottom up, as I said, start with physical, go. Top down, start with the application, go down. Divide and conquer, start wherever you want, and be chaotic. Okay. Isolating the issue, troubleshooting methods continued. Another approach involves comparing a working and non-working situation. So what we can do is, if we were making changes, since we documented our original working files, we can see the differences in the changes. If we use something like Putty actually has a thing that will show you where all the differences are, add-on built into it. We could also check, I don't know, software versions. I'd say, okay, we updated this, now it doesn't work. Hardware, we put this in, now it doesn't work. Why? Okay. The great thing about troubleshooting is you got to think outside the box and critically think. So a lot of times, you get it fixed and you really got to figure out why you got it fixed, but it is important for that documentation to work. Guidelines for selecting a troubleshooting method, pretty much common sense. Software troubleshooting tools. NMS, okay, network management system tools include device level monitoring, configuration, and fault management tools. Figure 1 shows display of What's Up Gold MMS software. These tools can be used to investigate and correct network problems. Network monitoring software graphically displays a physical view of the network devices, allowing network managers to monitor remote devices without actual physically checking them. Alright. Knowledge bases. Probably what you guys, when you guys Google it, that's what we're doing. Knowledge base. Remember, Cisco has the best, so if you can get on Cisco forums rather than places that are untrusted, that's what I do. And that's one of the reasons, if we use Cisco versus anything else, is Cisco has so much documentation out there that it is very easy to find solutions to your problems. So if there's ever a reason to use Cisco, you know, we complain it costs so much or something like that, the documentation is awesome. And then baselining tools, very common baseline. There's a couple of Linux applications built in that we can set in. They're completely free. Can't think what they are now, but it's showing some SolarWinds stuff as is mentioned before. But all these tools, there's tons of them. Most of them, some of them, they're getting a lot better. So they do like a single pane of glass where we just go to one screen and we can see all of our problems that are happening, and then dive into other monitoring stuff. But this stuff really isn't. The commands are more important for your CCNA than, you don't really have to know, oh, this software does this. You just need to know that, you know, documentation is super cool and important. Wireshark, I know everyone has used that because of security. Okay, network analyst model. As shown in Figure 1, a network analyst module can be installed in a Cisco Catalyst 6500 series switch or a Cisco 7600 series switch. NAMs provide a graphical representation of traffic from local and remote switches and routers. The NAM is embedded in browser-based interfaces. Digital multimeters, DMMs, such as the Fluke 179 shown in Figure 2. Here we go. Show us power, voltage, and that kind of thing. Cable testers, test cables. To notice that most of these are layer 1 solutions. Alright, then we have network analyzer. Holy, this would be an expensive one. Portable network analyzers like Fluke Optiplex and Figure 1 are used for troubleshooting switch networks and VLANs. You could also just use a laptop. Okay, so notice most of these are layer 1 because 85% of all network problems supposedly are layer 1. Syslog. Okay, so if you didn't get syslog the last time, here you go. We have our severity levels, we have our logging, and our trap. And so if we put notifications, what notification's doing is we're right here. It's giving us 5 and below. No, 5 and below. Sorry. On this. Anyways, so that's just setting up. That's the same as what we saw in the last chapter. Physical layer troubleshooting. What causes physical layers? Wires are bad, power related, hardware faults, cabling faults, attenuation, noise, interface, configuration errors, exceeding design limits, CPU overload, power related, data link, encapsulation errors, address mapping errors, framing errors, STP failures. Okay, so symptoms. We have a lot of blinky lights. We have no blinky lights. Console messages. Okay, that's the kind of thing. So this probably more common WAN. Besides the, I don't know, like a broadcast storm, which is where STP doesn't stop a loop. Here, common everywhere. If you've been around very many network guys and they have a guy just doing layer 1, they always blame the layer 1 guy because it's so commonly that poor fellow's fault, and usually it's probably theirs. Anyways, alright, network. You can't get somewhere. Suboptimal performance. Why? I don't know. We're not getting IP addresses. We don't see our neighbors. Our routing information doesn't work. Our routing table is wrong. General network issues, whatever that means. Transport layers. Notice it says ACLs. So basically, NAT or ACLs aren't set up right. That's about it. How can we tell? Well, we probably want to look at logging of our ACLs, and it's blocking what it should do. In some circumstances, we can just turn off our ACL and see if it starts working. Oh, BootP and DHCP. What do? Well, they're basically both DHCP. manage automatic assignment of IP version 4 addresses to clients. Alright? Anything more important than that? DNS. Oh, this is just transport. Say we block this stuff, bad stuff can happen. SMMP, simple network management protocol, right? Besides what we saw in the last chapter, SMMP also, if we block this stuff, it's what allows us to have connectivity to printers, like so our printers go transparent, things we can't get to it, that kind of thing. Tunneling, we could block ports that stop tunneling, stop BGP, that kind of thing. Application, well, all these application layer protocols, yeah, if they stop working, we got to figure out why. I don't really know what to tell you about that you can't. Just think of components, troubleshooting, end of connectivity. We're at IP version 6. I don't know. So IP version 6, if we're using Slack, probably what's our problem? We don't have a default gateway to the internet. We're just getting an IP address. I don't know. We can troubleshoot with a ping or a trace route. What are our verifications for our physical layer? So processes CPU, show memory, show interfaces, show interfaces, show interfaces, show interfaces. Typically, probably our layer 1, actually, could be layer 2. We have framing issues with show interfaces. Other things we're looking for input errors, output errors. If we are getting errors, it's going to tell us if they're runts, if they're giants, if they're being throttled. If this doesn't come up at all, we know we have a problem. Duplex. Okay, so duplex mismatches happen a lot sometimes when we have auto. The problem with these, if one negotiates full and half, it causes all kinds of weird stuff that we can't really. It's hard to see. Maybe half of our pings are successful, half of them aren't. Why would it do that? Because it's sending on half the pairs, and the other side is sending and receiving, right, on all the pairs. So half fail. Sometimes it'll stay orange for a long time. Sometimes it'll go down. Sometimes it looks like it's working. So duplex are probably the worst to check, and that would be one place where we do show interfaces once again. And if we're having problems, we could always, instead of doing auto duplex, we just say duplex full or duplex half, right? ARP, if we can't get somewhere, we can always check our ARP table, see if there's a reason that we can see why we are not getting somewhere, right? Because ARP, our layer 3 devices need that to map to the layer 2. We should ping our default gateway. They say show IP route or route print on our PC. See if we have a default gateway. We could also go into our configurations, be it PC or device, IP config, that kind of thing. But I would just start off. If I don't think I can get somewhere, I'm going to ping this default gateway. Then I'm going to ping wherever its next route is, see if I can get there. I'd probably ping this side of the router, then this side of the router, then here, then here, then here, then here. See where I can't get to. Why would I do that? To isolate where the problem is. Troubleshooting IP connectivity. Show IP routes. Ping. IP config / release / renew. I guess that's not necessary IP connectivity. Anyways. Successful telnet. Hopefully you guys have seen that before. Verifying ACLs. Show IP access list. Show IP version 6 access list. Look at what they're doing. Why are they blocking this? Do they have implicit deny? What happens if we change this? That's is it set on the right? Remember, probably our biggest place that we're going to have problems with ACLs is we wrote it for incoming, then we placed it outgoing. So remember, it's this interface. Some traffic goes this way, that's outgoing. Traffic coming in is this way. And so destinations and sources are going to be different whether it's coming in or out. So if you write it CCNA4 out and then set it in, or vice versa, it's not going to work how you want it to. Like, it's either going to block everything or it's not going to block what you want. Verified DNS. I think you guys have probably done that enough in your server classes. Alright, go ahead and try these packet tracers out if your heart so desires. But I think that was it, and I know that was this chapter's a nightmare to talk about because, in my opinion, it's mostly review besides maybe how to form a baseline and I don't know, that kind of thing. So, but actually, I mean, they've talked about baselines before in CCNA. So, I don't know. I guess that's it. That's CCNA4. Get ready for that CCNA. CCNA5 will be released pretty soon. There's a few tests that you have to take before you get to take that old CCNA. But anyways, enjoy.